Okay, right now we are moving on. So the data clustering. So the goal of data mining exploration to find hidden structure in large and complex data set that has some interests or value. Data clustering, a branch of data mining, so finds clusters of data points that are close to each other but distant from points of other clusters. If the data points were 2D and graphed as a scatter plot, it would be easy to draw boundaries around points and call them clusters. We would perform as well as any clustering method. The problem is when the points lie in more than 3D space, because we cannot see them anymore, and that is where cluster methods are valuable. Here we will cluster crimes using 4 attributes dimensions, including severity of the crime plus the race, age, and gender of arrested persons. A better attribute than race would be to use the poverty status of arrested persons, which is an underlying cause of criminal behavior, but that data is not collected by police. So a limitation of clustering, however done, is that there is no way of knowing true clusters in real data to compare against what a method determines are clusters. We will take that clustering methods provide, and we will get information or ideas from clusters patterns in the data. We can confirm them or determine their predictability using additional methods or other methods. Clustering is purely an exploratory method. There are no right or wrong clusters, only more or less information less. So here is a simple method called k-means clustering, which participations a dataset with an observation and p variables into k clusters. We will use a dataset with n equals 303 observations, p equals 4 valuables for clustering, and k equals 5 clustering cluster designed. K-means is a heuristic algorithm, as are all clustering method as a set of repeated steps that produces good, if not optimal, results for this tutorial data. The algorithm starts with a procedure that selects 5 4-dimensional 4D observations called seeds as initial centroids. Then each observation is assigned to its nearest centroids on the basis of Euclidean straight line distance in the 4D cluster variable space. Next, a new centroid is calculated for each cluster, and then all observations are reassigned to the nearest centroids. These steps are repeated until the cluster centroids do not move appreciably. So k-means clustering is a common sense mechanic method. So k-means measures that all attributes are equally important for clustering because of its use of distance between numeric points and its basis. To meet this assumption, all input attributes must be scaled to a similar magnitude and range. Generally, we will use standardized variable for each variable, subtract its mean, and divide by its standard deviation to accomplish scale parity, but other ways of rescaling are acceptable too. It is the range or relative distances between observations that is important in k-means clustering. The data used in here includes numeric, interval, or ratio, ordinal, and nominal classes data for classification. K-means clustering is intended for numeric data only because of its use of distance in cluster variable space. Nevertheless, with rescaling, it is possible to get informative clusters when including numerical data. Next, the discussion turns to the specific case at hand and how to rescale attributes. So the data used in here is serious violent crimes from a summer in Pittsburgh with data mapped as points. So the crime are ranked by severity using FBI's hierarchy numbers. 1 is murder, 2 is rape, 3 is robbery, and 4 is aggravated result, with, of course, murder being the most serious. Clearly, the nature of crimes should be important for their clustering. So the first assumption we must make is that the distance between serious bodily harm to another person is meaningful for clustering purposes. The criminal justice system agrees on the order, and for clustering we can accept the distances or change them using our judgment. So here we have lived them as listed. So next we consider the single numeric attribute that is available. The age of an arrested person. Crime is generally committed by young adults, tapering off with older ages. For the serious violent crime study here, age varies between 13 and 65, range of 42, with a mean of 29.7. Together with crime severity, age would dominate clustering because of its greater range. The remedy is to standardize age, which then varies between -2.3 and to 2.7 with a range of 5, whereas crime severity has a range of 3. So then both attributes are fairly equal in determining clusters. Finally, there are 2 nominal attributes: race, black or white, and gender, male or female. These can be encoded as binary attributes: race 0 equals white, 1 is black, and gender 0 equals male, 1 is female. As binary indicator variable, race has a mean, which is the fraction of arrestees who are black, and similarly gender has a mean, which is the fraction of arrestees who are female. These variables, as encoded here, would have perhaps lesser rows than the previous 2, but not by that much. If you wanted to increase the importance of the binary variables for clustering, you would encode them as 0.2 or 0.4 indicators. We will leave them as 0.1 variables, which makes interpretation of clustering results easier. So one last point is that we must choose the number of cluster instead of having k-means clustering. Find an optimal number here. That is the case for most clustering methods. For the crime data, experimentation with the 3 through 6 clusters resulted in 5 clusters being the most informative. We will run with 5 clusters. So in summary, the observation here is for the vector crime, standardized age, gender, race, for example, 1 and then -0.36400. It is a murder with an arrested 25 years old. Standardized age is 25 is -0.364, male who is white. The clusters found by k-means exist in the 4D space in which the observations lie. Each cluster is characterized by its centroid, which corresponding means and standard deviations of each cluster variable. Alright, so now we will go to the bookmark for Pittsburgh. Alright, so here the right here is the data clustering. For this one, of course we provide some background information, and we will integrate it here, and of course finding the age and looking at their rank, the hierarchy and everything. So now the map shows the spatial distribution of serious violent crimes by crime type with police zones. Each zone has a commander, station officers, and staff. Also shown out are the poverty areas here. Generally, there is a positive correlation between poverty and crime. So we will open the attribute table for serious violent crimes, scroll to the last column, and go to seed. So we'll go back to view, and then we will bring the contents back. Okay, and then we have violent crimes, serious violent crimes, and we go to open attribute table. Okay, and then we want the field crime age data. We will sort, scroll to last, right here, seed, okay. Alright, seed, and sort it descending. Okay, so there are 5 records used in initial cluster centroid as found by k-means clustering for a given run. Each time we will run k-means, the procedure has a chance of choosing different initial cluster centroids. So we will use these initial cluster centroids to get results consistent with the steps that follow. Hierarchy is the FBI code for crime types, and one of the 4 cluster attributes. A range age is the actual age of the arrested person, and a range age standard deviation. The second cluster attribute is the standardized arrest age. Notice that there is a good deal of variation in the cluster variables of the seed records, although the clusters that k-means ultimately finds are much different from these starting cluster centroids. As we will see, the remaining 2, 0, and /1 attributes, get gender and a range age, are the remaining cluster variables. Alright, so we will run the clustering algorithm. So the k-mean algorithm is a dual processing tool called grouping analysis. So grouping analysis, we will go to analysis and go to tools. Grouping analysis, okay. Alright, grouping analysis show up. It's right here. And we will open this tool and we will fill out the thing, and including typing the extension PDF. So for the output report file, we will use the tab key to move to a new field and ensure that we do not use the enter key, because doing so may run the tool permanently. So it's scary, okay? So for input, we will have a serious crime, and unique field, we will have a CNN, and then serious output feature class. Well, this I think I'm gonna just change that. Alright, so go to database. Yeah, we will say clusters. Go to save. Okay, and then number of groups, we will say 5. Alright, so we want hierarchy, and then we want arrange gender, we want arrange race, and the average. Okay, spatial, no spatial constraint. No spatial constraint. And distance method, and we will say Euclidean, and find seeds from field. Oh, no, find seed. Get seeds from field. Okay, get seeds from field. And initial fields, it will be seed, cluster report file, PDF. Let's find the PDF, cluster report PDF. Cluster report file, PDF. Not in chapter 4. Okay. Alright, so chapter 9, data. Where is the PDF? Tutorials, Scratch, Index. Oh my god. Data. Okay, then I will type out